Right, question 7. Here is some information from a 2014 Geographical Journal. So the population of the UK and the area of the UK given here, right? Using these figures, calculate the greatest possible value for the population density of the UK in population per kilometre squared, okay? So we need to basically see how many people are in each kilometre squared, okay? So lots of people here, but in lots of areas as well. So in 1 kilometre squared, what would the population be? So we're going to divide the population by the area, right? And it sort of gives you that idea there, population per kilometre squared. So population divided by the area, right? So you also got to look at here the fact that it's correct to the nearest million, correct to the nearest thousand. So, you know, bringing in boundary values there, okay? And when it says in the greatest, okay, to get the greatest population density, then, as I said, I'm not sure what to divide. Okay, well, it's here, isn't it? The population divided by the area, okay? But to get the greatest possible population density, when you're dividing, okay, in terms of boundary values, you need to have the greatest population on the top, divide by the least area. If you think about it logically as well, right? If you want to get the greatest sort of possible value for the density, as in how many people are in per kilometre squared, well, yeah, you want to pack in as many people as you can in the least area, and that will give you the densest possible sort of value for kilometre squared and so on. So the greatest population then, right, will be this here, the boundary values here. And here it says 6.5 times 10 to the power 7, correct to the nearest million. Okay, well, in terms of getting the greatest, what I would do first of all maybe is change this standard form into normal numbers, because 6.5 times 10 to the 7, we need to understand what this is, standard form. So 6.5, now the decimal point will move 7 places, 1, 2, 3, because it's power 7, yeah, 7 places right, so 1, 2, 3, 4, 5, 6, 7, so it'll move there. So you end up having 6, 5, and then filling in all these hoops with zeros. Okay, so actually then that's 65 million, isn't it? 65 million. So if it's the nearest million, right, our sort of number line would be then going up in millions, wouldn't it? When it says nearest million. So 65 million there. The next one would be 66 million. Okay, and the greatest it could possibly be then, of course, so that it rounds to 65 million, the greatest it could be is 65,500,000, okay? So you go in between those two there, all right? Now for the area, it's 244,000 to the nearest kilometre, sorry, to the nearest 1,000 kilometres. So again, to get the boundary values there, okay? It's going up in thousands. To the nearest 1,000, and we want the least area, we said, didn't we? So the least area then, because it's going up in thousands, will be here, so 243,500. Okay, so now we've got the least area, we've got the greatest population, and that then we can go back to this formula there to get the greatest population, okay, density, population density, by dividing greatest population by the least area. And that's important to remember. When you want the greatest and you're dividing, always put the biggest on the top, smallest on the bottom, okay? That will give you the biggest possible answer. So we got 268.99. Now we're talking about people here, aren't we? So, you know, it's sensible to round that up. 269 people per kilometre squared. Okay, so there's our population density answered there.